Okay. Now this lecture is going to take place in parts. Okay. So for the first part, we're going to talk about the basics. Okay. This is the part where I'm going to prove to you that the basic idea of a function is ridiculously easy. In part 2, we start to get into the complicating factors. We're going to talk about the details. There's a rule of assignment, something called domain and range. Part 3, we're going to talk about what it means for a function to be one-to-one. And part 4, we're going to talk about what it means for a function to be onto. Okay, on to the easy stuff. Part 1, the basics. We're going to play a little game. It's going to be Dora the Explorer style, where I'm going to pretend we're interacting, okay? So here's how the game works. I'm going to tell you, give me a number, and then I'm going to give you a number back, okay? So let's just pretend I say, okay, give me a number, and you say 5, okay? I say 6. Give me another number. Okay, you say 17, and I say 18. Give me another number. You say 1 million. You're getting a little smart with me. I say 1,000,001. Okay? Now, you probably see where this is going. You want to maybe throw a monkey wrench into the situation. So you say -1. I say 0. You say 12.7843. I simply reply 13.7843. Literally, that's all a function is. It's an input-output machine. That's it. Don't get yourself confused over what a function could possibly be. It literally is just this. It's an input-output machine. You input something, and then the machine outputs something else. Now, the function that I just pretended to be was very, very easy. How would you describe the function I just illustrated? You said 5, I said 6. You said 17, I said 18. You said -1, I said 0. Well, I mean, we know what the pattern is. But how do we encapsulate what that, how do we describe that function? Well, we could say, let's say we have a function that we'll call f. This is what it does. You plug a number in, then it will add 1 to that number and output that new number. Okay? This stinks. It does describe the function well, but who wants to write a paragraph every time you're talking about a function, right? Nobody. So we use notation, we use shorthand. Here's how we shorthand this particular function. Okay, here's our notation. We say f, and then in parentheses we put the input, equals. Then on the right-hand side there, we give the instructions on how to get an output using that input. Remember, a function is just an input-output machine. You put something into the function, and then it evaluates it and spits something back out. So this is the notation for it. F of input is equals, and then on the right hand side you put the instructions on how to evaluate that input to come up with an output. So in the case of this function, f of input equals input plus 1, right? See, isn't this so much neater and nicer than having to write a paragraph? And we can simplify this even further. I mean, we don't have to keep saying input, right? We just need a placeholder. So we use x as a placeholder. F of x equals x plus 1. See, what is this saying? This is saying, okay, we have a function, and whatever you plug into the function, it's just going to add 1 to it, and that's going to be the output. See how neat and easy that is? So let's use this. Now that we've shorthanded everything, what happens if I input 5? Well, if I plug 5 in instead of the placeholder, so where the input was being denoted by an x, it's just a placeholder, I'm actually going to put an input in, and it's going to be the number 5. So I actually input 5 into my function, and I get f of 5 equals 5 plus 1, f of 5 equals 6. Okay, in this video, we're going to get into some of the details of a function. We're going to talk about something called domain, rule of assignment, and range, and then we're going to play is it a function or not, where you get certain rules and then you decide whether the rule being explained is a function or not. Okay, so let's start with domain. So when you give a function, you have to say what the input values are. You must provide the input values. Okay, so let's look at an example. You can't just say, here's a function, figure it out. You have to say, this is a function on the real numbers, or this is a function just on the integers. You have to literally state what your domain is, and the domain is what input values you can put into the function. For example, is the following a function on the real numbers? Okay, this is called a blackboard R. It represents the real numbers. So my question is this a function on the real numbers? So what does this function tell you to do? You plug something in, okay, so whatever you plug in, you add 3 to it, and then you divide that by the plug-in minus 1. And my question is this a function on the real numbers? It turns out that this is not a function on the real numbers. Again, the key is on the real numbers. To be a function on the real numbers, it would mean that for any real number, you could plug it in and get an output. So you might be wondering, well, what's wrong with this? Well, remember, you can't divide by 0. Dividing by 0 is undefined. So here, this function is a real number. This is a function on the real numbers, except 1. Okay, so if I tell you this is a function on the real numbers, I'm lying, because 1 is a real number, and I can't plug 1 into this function, because you would end up 0 in the denominator, and we don't know how to divide by 0. It's undefined. So what can we do? Well, we could say that the domain is all real numbers except 1, and we could illustrate this a couple ways. You could do the R, and this backslash is a minus sign when you're talking about sets, and you take out 1. And I use curly braces here because when we're talking about domain, we're talking about sets of numbers, so this is the proper notation. So R backslash 1, all that this is saying is look at the set of all real numbers except 1. Another way we could get the same point across is, I don't know if you've seen interval notation before or no, but I wanted to have it here in case this is how you see it in your textbook. See, this says all the way from negative infinity to 1 is good. I can plug in any of these numbers from negative infinity. Your lower bound is on the left, your upper bound is on the right. The reason I use a parenthesis here is because I'm saying not actually 1. If I had a bracket, a square bracket, that means you could include 1. This parenthesis here just ensures that every number from negative infinity all the way up to 1, but not including 1, combined with, this means union, every number that's not starting at 1 but not including 1, all the way to infinity. All that this notation is saying is start from negative infinity, go up to 1, skip 1, and now go any number bigger than 1 is okay. So we can plug any of these numbers into the function. So this isn't a function on the real numbers. It is, however, a function on the real numbers minus 1, or you could say a function on the real numbers from negative infinity up to 1, not including 1, and then from 1 to infinity, again, not including 1. They both say the same thing. Basically, any number except 1. Okay, so to summarize detail 1, whenever you state a function, you have to say what the input values can be. And we refer to the entire collection of input values as the domain, okay? This is my domain. This is where the function lives. So where the function lives, that's the domain. That's the numbers, or that's the things that you can input into the function. Now, there's a rule of assignment. And there's just one rule to a function in terms of what it can spit out. And the rule is every input can have only one output. You can't have a function where I plug something into the function and that it spits out 2 or 3 or 4 different outputs. It doesn't work that way. It's not like a decision where, okay, this is where I live, this is the kind of work that I want to do, if you're looking on a job search site, and then you get a bunch of different job listings come up. It's not like that. That wouldn't count as a function, only because it's outputting multiple values. With the function, one input can only have one output. That's it. That's the only rule. You can't have multiple outputs to a single input. Now, is f of x equals plus or minus the square root of x a function on the real numbers? The answer is no, specifically for this reason. Let's focus on why this isn't a function in this particular sense. Notice that numbers will have more than one output. See, because we have a plus minus, that messes this up. This is not a function because it's going to spit out both a positive number and a negative number. For example, what if I plug 4 into my function? So I'm asking, I plug 4 into my function. I take the square root of it. I want plus or minus the square root of 4. Well, if I plug 4 into my function, it's going to spit out plus or minus the square root of 4, which simplifies to 2, right? Because the square root of 4 is 2. So plus or minus the square root of 4 simplifies to plus or minus 2. That disqualifies this thing from being a function. Because, for example, if you plug 4 in, the function will output negative 2 and 2 for a single output. Okay, and we can't have that with a function. In order to be a function, one input value can only produce one output value. So a plus or minus is a big red flag. If you see it on a homework question, it says, is this a function? If you see plus or minus, you can confidently say no, because every number except 0 is going to produce both a positive number output and a negative output. So it's no good. Okay, so those are the first two details. Detail number 1, when you give a function, you have to say what the input values are. That was the first detail. The second detail, you can't have multiple outputs. Okay, one input should only have one output. Now those are hard and fast rules. This next thing we're going to talk about is more just terminology, but it's important as it relates to another rule, which we'll cover later. We call the collection of all our outputs the range of a function. So, let's consider an example here. Define a function on the integers by f of x equals 2x, okay? So plug in a number, any integer. So I can't plug in numbers like 2.5. I'm only looking at integers right now. 0, -1, +1, -2, +2, okay? If I plug those into my function, my question to you is, what would my range be? So again, range is the collection of all outputs. Now let's think about this. Any number I plug in, I'm just going to multiply it by 2. So if I plug 0 into my function, 2 times 0 is 0. If I plug 1 into my function, 2 times 1 is 2. If I plug 2 into my function, 2 times 2 is 4. Okay, so by plugging in 0, 1, and 2, my function is spitting out 0, 2, and 4. If I plug 3 in, what does my function spit out? 6. So 0, 2, 4, 6. So hopefully you can picture what this function is doing. When you multiply every integer by 2, the function is going to spit out all the even integers. So the range of this function would be all the even integers. So this is a function from the integers to the integers. Why is it a function from the integers? Because you can plug any integer into this function. Why is it a function into the integers? Because every single number that this function spits out is going to be an integer. However, the range is just going to be all even integers. This function isn't going to spit out a number like 3 or 11, okay? It just doesn't. This function just spits out all the even integers when you're just plugging in integers, okay? So that is what we call range. We call range, that's what we mean by range, is the collection of all outputs. Now, in the next part of the video, what we're going to play is it a function or not? You may have homework problems like this.